Hello friends, good morning. In my previous lecture, I had explained how three-step distance protection scheme is implemented using impedance relays. We had seen that as the impedance relay is non-directional, along with three impedance measuring units, we had to use one directional unit. Total four units are required, three for impedance measurement and one for direction sensing. Today I will explain implementation of three-step distance protection scheme by more relays. We'll take the same example, three line sections, radial feeder having source at both the ends. Sections we name as AB, BC and CD. We use relay R1, R2 for section AB, R3, R4 for section BC and R5, R6 for section CD. As sources are at both the ends, we need the directional sense for the relays. So the directional sense are marked here. Now let us consider relay R3. We are considering relay R3 because by considering relay R3, we are able to show the faults in all three steps, that is F1, F2, F3, as well as fault in the reverse direction also, that is F4. Now R3 is more relay. So it will sense the impedance and operate accordingly. So in the first step, as per our rule, we select 80% of line BC, that is 0.8 of 80% of its own section, so 0.8 into ZBC. And operating time is without any time delay, let us say it is T1. In the second step, we cover entire line BC plus 50% of next line section, and operating time for fault T2 is T1 plus delta T. And in the third step, as there are only two lines, we select ZBC plus ZCD as the impedance setting, and operating time T3 is T2 plus delta T. Now, I will explain this scheme on RX diagram, how these three impedance measuring more units are used and how is their characteristic in RX diagram. So in RX diagram, we locate the relay at origin. So this is point B. Relay BC is the line. This is line CD and this is line AB. This does not indicate that the line is having negative resistance and reactance, but this simply indicates that this line is below before the location of the relay. So after drawing the characteristic of the line, we draw the characteristic of the relay being used for protection. In this case, we are using more relay. So more relay characteristic is a circle passing through origin, having diameter is equal to impedance setting of the relay at angle tau degrees with respect to the resistance axis. So this is characteristic of first Mo element. This is the characteristic of second Mo element. First element 80% of line BC, second element BC plus 50% of CD, and third element has diameter is equal to BC plus CD. So these are the characteristic of corresponding Mo elements. After that, we locate the faults in the same RX diagram. F1 is the fault in the first region, F2 in the second step, and F3 in the third step, and F4 is the fault in section AB. Now let us see which elements will operate for which fault. Fault F1. Now if you observe fault F1, it is coming in the positive torque region or operating region of first element, second element as well as third element. So all these three elements will operate for fault F1. Fault F2 is not coming in the operating region of first element, but it is coming in the operating region of second element and third element. So only second and third element will operate, first element will not operate. Fault F3 is coming only in the operating region of third element. So only third element will operate. F4 is outside the protected zone or operating region of all three elements. So none will operate. And our requirement is for fault F1, operating time should be T1. For F2, it is T2, that is T1 plus delta T. And for F3, it is T3, that is T2 plus delta T, and F4 no trip. Now let us draw the contact diagram to implement this scheme. Now let us see how our requirement is fulfilled by means of this contact diagram. Actually, this is trip circuit. Thus minus 110 volts DC supply, Z1, Z2 and Z3. These are the normally open contacts of no element. This is trip coil of the circuit breaker. This is timer coil. T2 and T3 are the contacts of timer's element. For fault F4, none of the element is going to operate, so trip coil of the circuit breaker remains unenergized. For F1, that is fault F1, it is in the operating region of all three elements, so Z3, Z1 and Z2, all three elements will operate. So here you can see, as soon as Z3 and Z1 operate, trip coil is energized, and that is our requirement. For fault F1, relay should operate without any intentional time delay, without any time delay, so it is operating. For fault F2, Z1 will not operate. Z2 and Z3 will operate. So Z2, Z3 they are operated. So trip coil is not energized instantaneously. Now as Z3 is operated, timer coil or timer circuit will be energized. And after time T2 seconds, this contact will close. So now the trip coil will be energized through Z3, Z2 and T2. So our requirement is fulfilled. For fault F3, only Z3 will operate. So as Z3 has operated, timer coil will be energized. After time T2 seconds, this contact will close. Now as Z2 is open, timer trip coil will not be energized. After time T3, that is T2 plus delta T seconds, this contact will close and the trip coil will be energized through Z3 and T3. So here by means of this we can see that our requirement is fulfilled. Now in this case, this third element is operating for all the faults. Therefore, it is called as fault detector or starting element. Z2 and Z1, they are measuring the impedance. They are called as measuring elements. So Z3 acts as measuring element as well as fault detector or starting element. Now, if we compare this scheme with the previous one, we observe that in this case, no additional directional element is required. In previous case, when we were implementing three-step distance scheme by impedance relays, three impedance measuring units and one directional unit is required. So total 4 elements are required. When we are using more relay, we require only 3 units, that is 3 more elements. We don't require any additional directional element because more relay itself is directional relay. Similarly, in place of more relay, if we use reactance relay, that is also non-directional. So along with 3 reactance measuring elements, we'll require one additional element, that is the directional element. So this is how the step distance protection scheme is implemented using more relays. Friends, if you feel this video lecture useful, then like it, ask your friends, your colleagues, your juniors to subscribe to my channel for upcoming video lectures on power system protection and high voltage engineering. If you want to make effective and efficient use of time, then read my book on time management. Link for the book is given in the description box. I have launched a useful course for the students on UDEMY. The title of the course is Boost Your Learning and Become Top Achiever. The link for the course is also given in the description box. This course is useful for students who are preparing for competitive and entrance exams. Thank you.